Hello, and welcome to the Wondering Atom, your peaceful corner of the cosmos, where curiosity drifts slowly and science gently rocks you to sleep. Before we begin tonight's starlit journey, I'd truly love to know where you're listening from and what time it is as you settle in. Share it in the comments below. I'm always amazed by how many of us gather here quietly, tuning in from every corner of the world. And if tonight's story helps you unwind, even just a little, consider giving the video a like and subscribing to the channel so you won't miss our next evening of cosmic calm. It really does help more curious minds find their way to this gentle space. Now, as for tonight's story, it's a lovely one. It's all about galaxies, those vast, starry cities, and how they rise from darkness and dust. I hope it's not so captivating that it keeps you awake. But if it is, at least you'll drift off knowing a little more about the origins of the universe. So go ahead and relax. Let your limbs grow soft. Take a deeper breath. You're about to float through 13.8 billion years of celestial memory. Don't worry, the stars aren't going anywhere. Take your time. Let's begin. Chapter 2. The Universe Awakens. Around 13.8 billion years ago, the universe was unbelievably small. Not just tight like a cramped elevator or an overpacked dorm room, but almost unimaginably compressed, hotter than the core of any star, and denser than a physicist's inbox during Nobel Week. Then, in a moment we still struggle to fully grasp, it all began. It wasn't an explosion, despite what the name might suggest. The Big Bang wasn't a bang at all. It was a swift, graceful expansion. Space itself unfurled in all directions, faster than light, like a balloon inflated by a pump with no limits. There weren't fragments flying through space. Space was the fragments. It was the thing unfolding, stretching, shaping itself as it grew. In those first slivers of a second, the universe was a seething broth of primal ingredients. Quarks crowded up against gluons, photons darted chaotically like toddlers let loose after candy, and gravity, always the quiet sculptor, started tugging, ever so gently, at the chaos. It was blindingly hot, violently unstable, and completely inhospitable, certainly not a place for stargazing or cozy campfires just yet. Still, amid the intensity, something remarkable was taking shape. Hydrogen and helium, the lightest, simplest elements, began forming from the charged maelstrom, snapping into place like interlocking cosmic puzzle pieces. These atoms would eventually build everything: stars, planets, hummingbirds, galaxies, and, somehow, us. Roughly 380,000 years later, a cosmic blink, something subtle but monumental occurred. The universe had cooled just enough for those free-floating particles to settle down and bond with electrons, forming neutral atoms for the very first time. Light, which had been trapped like a firefly inside a jar, suddenly slipped free, racing across the infant universe. That moment, known as recombination, gave rise to the cosmic microwave background, a soft, residual glow from that initial fire, still rippling gently through space today. If we could see microwaves with our eyes, the entire night sky would shimmer with that ancestral flame. And yet, for all the light, there were still no stars. No spiraling galaxies. Not yet. At that stage, the universe was a vast, dark fog, quiet, featureless, and full of potential. If you could have floated through it, you'd see little more than a uniform gray haze, broken only by the slightest hints of unevenness. Those tiny variations? They were everything. They were the stretched echoes of quantum ripples from the very beginning, scattered across the fabric of space by cosmic inflation. In some spots, matter was just a touch denser, just slightly more concentrated than elsewhere. Almost imperceptible. But gravity noticed. And gravity never forgets. Over eons, those denser regions began to pull in stray atoms. A slow, almost tender process of gathering. Like beads of dew forming on a strand of silk, matter started to cluster. These invisible clumps, undetectable by any eye, had there been one, were the earliest outlines of what would eventually become galaxies. It might sound strange to describe the young universe as quiet, but in its way, it was. No stars. No luminous clusters. Just a patient hush as matter drew itself inward. A breath being held. A pause before brilliance. Even now, with all our telescopes and theories, we still don't fully understand what happened next. How did those faint, random ripples turn into sweeping, majestic galaxies? Why did some regions burst with stars, while others remained empty and cold? The answers are scattered across the cosmos, hidden in every glowing nebula, in every ancient star cluster, in every spiral arm of every galaxy. And so the universe kept changing. Dark matter, that unseen framework beneath everything, began to shape the layout of the cosmos, bending and pulling the paths of everything around it. Hydrogen flowed along these invisible highways, guided by gravity's quiet call. And the universe listened. Soon, the first stars would flare to life. Darkness would yield. But in that moment, something had shifted. The universe wasn't just expanding anymore. It was starting to become. Chapter 3: The Cosmic Dark Ages. The stars hadn't arrived yet. Galaxies were still waiting their moment, and for several 100 million years, the universe remained cloaked in what we now call the Cosmic Dark Ages. The name might sound theatrical, but there were no castles, no epic battles, no dragons, unless you count the ones made entirely of plasma and hydrogen. This was darkness in its purest form, a universe full of matter, yet utterly devoid of light. After the brilliant debut of the Big Bang and the soft fading glow of the cosmic microwave background, things grew quiet. Space became saturated with neutral hydrogen gas, a vast, invisible fog stretching in every direction. No stars pierced through it. No galaxies twinkled in the distance. The universe hadn't dimmed because it lacked energy, but because it hadn't yet discovered how to turn the lights on. Imagine drifting through that era, an endless, expanding sea of cool hydrogen and helium, where the occasional electron passed like a lonely jellyfish. Gravity was doing its quiet work, gently tugging at the gas, gathering it into isolated clumps. But the process was painfully slow. Not that time meant anything back then. There were no clocks, no days, no sunrises, just mass, slowly piling up in a universe that hadn't yet learned urgency. And yet, in the stillness, something profound was taking shape. During inflation, that brief, furious burst of expansion following the Big Bang, tiny quantum wrinkles had been stretched out across the fabric of space. These subtle variations in density didn't look like much, but gravity noticed them. Wherever matter was just slightly thicker, it began to draw in more matter. Over hundreds of millions of years, these gentle ripples stretched and curved, forming strands and junctions, the early scaffolding of what we now call the cosmic web. Picture the universe like a vast sponge or a three-dimensional spiderweb, woven with tendrils of gas and dark matter. Along these threads, galaxies would one day gather, pulled into place by gravity's persistent tug. And between the threads, vast emptiness, cosmic voids, silent expanses where stars would rarely, if ever, ignite. At the heart of this hidden structure was the universe's quiet backbone, dark matter. It doesn't glow, it doesn't reflect, and it has no interest in light. That makes it infamously hard to detect. Not exactly the life of the party, but absolutely essential. Dark matter's gravity was the architect. It shaped the cosmos, drawing regular matter, mostly hydrogen and helium, into the right places, like the unseen framework beneath a painting. Without it, the universe may have stayed nothing more than a dim haze. And if you're still with me, and if so, I genuinely applaud your attention, you might be wondering, Why did it take so long for stars to appear? The truth is, stars aren't just clouds of gas waiting for a switch to be flipped. Hydrogen had to gather densely enough for gravity to take control, compressing it until it reached temperatures of millions of degrees. Only then could fusion begin, the fiery chain reaction that powers every star. But the early universe was in no rush. It let gravity take its time, slowly and patiently pulling the gas into tighter and tighter knots. Gradually, the clouds collapsed under their own weight, until eventually, in one of those dense pockets, something extraordinary happened. A spark, a flicker, a first light in the vast Black Sea. And in that instant, everything changed. But for now, in this long, quiet stretch of waiting, the universe remained in a suspended breath, like an orchestra settling in the dark before the first note. The instruments were tuned, the stage was set, but the music had not yet begun. No stars, no galaxies, just the growing tension of something incredible about to unfold. And maybe that's the most reassuring part of this dark chapter. Even in the absence of light, the universe wasn't still. Beneath the silence, it was dreaming, planning, composing. The glow was coming. Chapter 4. The First Light. And then it happened. Deep within a collapsing cloud of hydrogen and helium, gravity kept pressing inward. At the center of that dense, invisible swirl, pressure surged and heat spiked to incredible levels, millions of degrees. Atoms were pushed so close together that their very identities began to change. And in that unceremonious instant, likely unnoticed by anything, a star was born, the first light since the Big Bang. But these weren't your ordinary stars. Known as Population 3 stars, they were nothing like the ones we see today. They were massive, unstable, and unbelievably hot, forged in the purest cosmic conditions imaginable. No heavy elements. No carbon, oxygen, or iron. Just hydrogen, helium, and trace amounts of lithium, the leftover materials from the Big Bang. This simplicity allowed them to burn far hotter and faster than modern stars. Some may have been hundreds of times the mass of our sun, flaring into brief brilliance before collapsing into black holes or detonating in spectacular supernovae. If you happened to be floating nearby, you wouldn't have stood a chance. You'd have watched these primitive stars piercing the darkness like campfires scattered across a vast and ancient wilderness. One by one, their light began slicing through the hydrogen fog that had cloaked the universe since its beginning. Gradually, the darkness receded. This phase is known as cosmic reionization. And though it sounds like the scheme of a sci-fi villain with a space laser, it was actually a gentle, though transformational shift. Ultraviolet radiation from those newborn stars began stripping electrons from the surrounding neutral hydrogen, ionizing it and making the universe transparent again. Like slowly cracking open a curtain in a foggy greenhouse, light began to pour in. From where we are now, we can't directly observe those first stars. They were too fleeting, too distant, and their glow too faint. But their legacy is written across the sky. They turned the universe from cold and dark to warm and glowing, the first to forge heavier elements, the seeds of everything more complex than hydrogen, including you, me, and possibly the warm drink in your hand right now. In a way, they were the cosmos' first artists, sketching the earliest outlines of galaxies across space's blank canvas. But actual galaxies hadn't arrived. Not yet. These early stars, often grouped in loose clusters, held together by gravity, but not yet formed into the grand spiraling cities of light we recognize today. They were more like villages, primitive blueprints for the galaxies to come. Still, the pieces were falling into place. As those massive stars reached their fiery end in supernovae, they scattered their enriched guts into nearby gas clouds. These now metal-rich clouds cooled more quickly, collapsed more easily, and formed stars faster. A new generation began. These were the Population 2 stars, smaller, steadier, and more familiar to us. The great stellar cycle had officially begun. Gas drawn in by gravity. Stars igniting, burning,
dying,
leaving behind enriched material for the next wave of stars. Each round layering complexity atop the last, like cosmic sediment built from stardust. You might ask, how do we even know any of this happened? We can't see it firsthand, but the clues remain, patterns of light etched onto the glass of the universe itself. By studying ancient galaxies, analyzing the chemical fingerprints of the oldest stars, and listening to the faint echo of the cosmic microwave background, astronomers can piece together the story of the universe's childhood. Like reading a forest's history through its tallest trees, its soil, and the prevailing winds, the signs are faint, but they're there. And now, finally, we're catching glimpses. Thanks to telescopes like the James Webb, we've begun peering into that deep, ancient cradle, spotting the first galaxies forming, tiny, chaotic, glowing swarms of stars dating back just a few 100 million years after the Big Bang. We're witnessing the places where light first took shape. It's humbling. These stars lived and died long before our solar system was even imagined. Their light crossed billions of years, past colliding galaxies, drifting black holes, and a growing Milky Way, until it gently touched the mirror of a telescope. And now that same light rests quietly in your mind, in the stillness of your night. The universe, once dark and dormant, had lit its first lanterns. Night was ending. The age of galaxies was near. The universe glowed, not brilliantly, but like a faint dawn over a frosted plain. The stars had come. Their glow unraveled the haze and brought warmth to the quiet. But they were still few, scattered, isolated, burning alone in the vastness. No cities, no roads, just sparks flickering in the dark. But gravity had other plans. These stars weren't merely floating, they were being pulled toward each other, drawn by invisible filaments threading through space. Everywhere you might have looked, if your eyes could see ultraviolet and your patience spanned eons, you'd have noticed clusters converging. Gravity was weaving. Stars began to cluster into larger, more intricate forms. The villages became towns. The towns began to look like cities. And these early cities were rough drafts of the galaxies we now know. It wasn't elegant. There were no cosmic blueprints. No divine architects drawing spirals with celestial compasses. It was wild, chaotic. Galaxies smashed together, ripped apart, merged again. Gas clouds slammed into one another. Stars were flung out and caught in the gravitational tug-of-war. Some galaxies grew fast, gobbling up gas and swallowing smaller groups. Others stalled, tucked away in quiet corners of space, like shy guests at a cosmic party. They didn't yet resemble the elegant spirals or sprawling ovals we see in telescope images. They were unruly, asymmetrical, messy, and yet they were evolving, slowly shaped by gravity and their cosmic neighborhoods. Much of this structural change was guided by something even larger, the cosmic web, a colossal three-dimensional net of matter stretching across the universe. Where threads of dark matter intersected, dense nodes formed, fertile ground for galaxies to gather, like seeds in rich soil. Long filaments connected them, guiding galaxies along unseen highways of gravity. And between these filaments lay the great voids, vast, silent spaces where galaxies rarely took root. In those dense intersections, galaxies found both promise and peril. Where gas and gravity pooled, drama was inevitable. Galaxies didn't collide like cars. Stars were spaced too far apart for direct crashes. But gravity was merciless. Tidal forces twisted galaxies, distorting them into strange shapes. Streams of stars were stretched thin, trailing behind like sugar pulled into ribbons. Gas clouds slammed into each other, igniting fresh bursts of star formation, what astronomers call starbursts. New stars flickered to life. New clusters took shape. And gradually, What once looked like a clump of chaotic light began to resemble something familiar. What if find a galaxy's final form? We're still trying to figure that out. Galaxies that evolved quietly, with a bit of spin and not much interference, became elegant spirals, like our own Milky Way. Others, battered by collisions or born in crowded neighborhoods, turned into ellipticals, rounder shapes filled with older stars. And some never quite settled, remaining jagged and offbeat. We call them irregular galaxies. And honestly, we admire them for it. But regardless of their quirks, galaxies became something new, something lasting. They turned into factories of light, places where gas and gravity continued their ancient collaboration, birthing stars, recycling ash, and layering the cosmos with elements.
Carbon,
Oxygen,
iron,
the fuel for everything that followed. Chapter 5: From Stars to Cities. Over billions of years, this continual recycling of stellar remnants gave rise to planets, moons, atmospheres, and eventually, at least once, a small blue world where someone would one day whisper these stories into a microphone. It's easy to forget, when gazing up at the night sky, just how long galaxies have been shaping themselves. The stars you see above are rarely first generation. Most are second, third, or even fourth generation stars, born from the remnants of those that came before them. Galaxies are the universe's memory banks. Each star is a snapshot. Every swirling gas cloud, a story waiting to be told. As galaxies grew, they didn't remain alone. They began to gather, forming clusters, groups, and vast assemblies called superclusters. Just as stars collect to form galaxies, galaxies themselves aren't solitary creatures. They orbit one another, tug gently with gravity, and sometimes meet in slow, sprawling collisions that unfold over eons. Our own Milky Way lives in one such gathering, a relatively calm region called the local group, where it shares space with Andromeda, Triangulum, and dozens of much smaller galactic companions. But that story comes later. For now, the universe had reached another turning point. It was no longer just a fog of energy and vapor. It had structure. It had complexity. It had communities. The stars had settled in, and the universe had begun organizing its own brilliance. Chapter 6: The Architecture of Galaxies. By this point in cosmic history, the universe was far from empty. Galaxies had taken shape, some modest and compact, others sprawling and dramatic. Stars traced immense orbits, and vast gas clouds shimmered with the light of newborn suns. Darkness hadn't vanished entirely, but it had retreated, peeled back like a vast cosmic curtain to reveal the grand stage of creation. And on that stage, galaxies had begun sculpting themselves. But galaxies don't all look alike. They appear in an astonishing range of shapes and sizes, a bit like snowflakes, if snowflakes happen to weigh hundreds of billions of suns. Some spin with grace, like celestial pinwheels. Others are short, round, and dense, glowing dumplings drifting silently through the void. And a few, bless their chaotic forms, resemble what someone might sketch from memory during a roller coaster ride. So, what determines these shapes? Why do some galaxies spiral, while others appear elliptical or formless? The answer, once again, lies in time, vast stretches of it, in gravitational influences, and in the slow, deliberate nature of cosmic evolution. Let's start with spiral galaxies, the showstoppers of the galactic world. Spiral galaxies rank among the most breathtaking structures in the universe. They're the ones plastered across science posters, desktop wallpapers, and slow-motion space documentaries backed by orchestral soundtracks. With their sweeping arms and radiant centers, they look like storms frozen in time. Our own Milky Way is a spiral. We live in one of its arms, a small neighborhood on the edge of a spinning, star-filled metropolis. Spirals tend to be rich in gas and dust, the key ingredients for forming new stars. That's why their arms sparkle with young, Hot stars like string lights wrapped around a massive rotating wheel. A spiral galaxy's shape is all about motion. When gas and stars maintain a steady rotational momentum, what physicists call angular momentum, the galaxy gradually flattens into a disk. Within that disk, density waves ripple through the gas, compressing it and triggering waves of star formation. This creates the familiar spiral arms, not as solid structures, but as patterns that move through the galaxy like traffic jams moving along a highway. Stars drift in and out of the arms, but the pattern itself remains visible. Still, not all galaxies settle into this neat configuration. Enter elliptical galaxies, older, rounder, and generally more reserved. These galaxies lack the distinct spiral arms. Instead, they appear as glowing spheres or ovals, like cosmic rugby balls filled with stars. Their populations are older, cooler, and dimmer. They hold little gas, which means star formation has largely wound down. If spirals are bustling cities full of growth and activity, ellipticals are more like quiet retirement communities, stable, slow-moving, and content to rest. Elliptical galaxies likely form through galactic mergers, especially when two spiral galaxies of similar size collide. Their ordered rotation becomes chaotic. Stars are thrown into random orbits. Gas is either used up in the resulting burst of star formation or expelled entirely. The end result? A featureless, glowing mass. It's violent, messy, but somehow still productive, like crashing two snow globes together and letting the fragments resettle in a new shape. And then there are the irregular galaxies. These are the wild cards, galaxies that break all the usual rules. Some are young and haven't yet formed a stable structure. Others are older, but their form was distorted by a close encounter with a larger galaxy, pulled out of shape like a hat knocked sideways by the wind. Irregular galaxies often appear like smudges or scattered paint splashes. Yet they're frequently full of new stars, bursting with activity and potential. Some galaxies blur the lines between types, spirals with oversized central bulges, ellipticals with rings, or other hybrids. The system astronomers use to classify galaxies, like much of the universe, is messy. Still, we categorize them, because humans love to sort things, even stars. A galaxy's shape, though, isn't just cosmetic. It holds vital clues about its past. A tidy spiral likely had a peaceful upbringing, steady gas infall, some gentle mergers, but no major cosmic drama. An elliptical probably survived one or more large-scale collisions, its structure scrambled by ancient chaos. Irregulars might just be young or simply unlucky. And perhaps the most incredible part? Galaxies don't stay frozen in time. They evolve. A spiral can eventually become an elliptical. Small galaxies can merge into massive ones. Gravitational interactions twist arms, distort cores, and fling stars into space. Nothing in the universe stays still, least of all galaxies. The Hubble Space Telescope helped bring this dynamic variety into focus. Through its lens, we've seen galaxies at every stage of development, from tiny, chaotic baby galaxies in the early universe to majestic spirals and massive ellipticals closer to home. We've watched them collide, stretch, and reform. Every galaxy tells a story, and sometimes that story is written into its shape. So the next time you see an image of a galaxy, maybe a flawless spiral with glowing blue arms, a bright elliptical dome, or a chaotic cluster of scattered stars, remember this. You're looking at a tale billions of years in the making. A story sculpted by gravity and time, by stars that lived, burned, and died. By drifting clouds of gas that collided, transformed, and became something more. Galaxies don't just shine. They remember. Chapter 7. Our Galactic Home. Let's come home for a moment. We've been drifting across the vast cosmos, watching stars ignite and galaxies take shape with breathtaking beauty. But now it's time to return to our tiny corner of the universe, a place familiar not because we've seen it from the outside, though we've certainly tried, but because every morning, every breath, every story we tell has unfolded right here. We live within a galaxy called the Milky Way, and she's been a generous host. From our position inside her sprawling arms, we can't view the Milky Way as a whole. It's like trying to read the label on a jar while you're still sealed inside it. What we can see is a hazy band of light stretching across the night sky, best visible from remote places, far from city lights. That glowing ribbon, made of starlight and cosmic dust, is our edge-on view through the galactic disk. We're looking sideways through billions of stars. The Milky Way is a spiral galaxy, and a sizable one at that, stretching roughly 100,000 light-years from end to end. It contains somewhere between 100 and 400 billion stars. Why such a large range? Because counting stars from within the galaxy is hard. We're peering through dense dust clouds, relying on telescopes and a lot of patience to make estimates. Current calculations place our solar system about one-third of the way out from the galactic center, nestled in the Orion Arm, cosmic suburbs, if you will. We're close enough to feel the galaxy's rhythm, but far enough from the chaos at its core. At the center lies a bustling and volatile region, anchored by a supermassive black hole known as Sagittarius A*, a gravitational heavyweight roughly 4 million times the mass of our Sun. It's not particularly luminous, nor does it feed as voraciously as some black holes, but it commands the galaxy. Stars whirl around it in eccentric orbits, like fireflies drawn to an invisible flame. We don't observe it directly. Instead, we watch how stars behave nearby, how they dart and loop, pulled by an unseen force. Decades of observations have made the conclusion clear. Something incredibly massive, incredibly dense, and incredibly powerful resides at the heart of our galaxy. And no, it's not coming for Earth anytime soon. The Milky Way didn't start out looking like the elegant spiral we know today. Like all galaxies, it has a long, often messy history. It grew gradually, over billions of years, by drawing in and merging with other galaxies. To borrow astronomical business speak, smaller galaxies were acquired, digested, and integrated into the Milky Way structure. Stars from those ancient galaxies still roam our galaxy's halo, tracing long, arcing paths, like ghosts adrift from forgotten realms. And the process continues. Even now, the Milky Way is absorbing smaller galaxies. The Sagittarius dwarf galaxy, for example, is being gently tugged in and stretched apart. It's not violent, not by human standards, but over millions of years, it's like watching ink slowly swirl through water. More dramatic still is what lies ahead. The Milky Way is drifting toward its nearest large neighbor, the Andromeda Galaxy, at about 110 kilometers per second. It's still 2.5 million light-years away, so don't panic. We have about 4 billion years before the two collide. And when they do, it won't be apocalyptic. In fact, they'll likely merge into a single, larger galaxy, perhaps elliptical in shape. Astronomers have suggested a name for the result, Melcometa, which admittedly sounds more like a space-themed yogurt brand, but the sentiment holds. What's truly remarkable is how much we've discovered from our vantage point inside the galaxy. Using radio telescopes, infrared imaging, and decades of calculations, we've traced the spiral arms, mapped star populations, and even built models of the galaxy's past and future. It's like trying to complete a puzzle from the inside, only to realize the final image is more magnificent than we ever imagined. Meanwhile, our humble sun continues its quiet orbit. It takes about 225 million years for the sun to complete one full lap around the Milky Way. Since its formation, it's completed only about 20 such orbits. To put that in perspective, the last time we passed through this particular region of the galaxy, Earth had just begun to welcome the first dinosaurs. In galactic terms, time isn't measured in birthdays, it's tracked in entire geological ages. And here we are, spinning quietly within one of the galaxy's arms. A small, pale planet circling a perfectly average yellow star, wrapped in the light of billions more. Every molecule in your body, every atom, was forged in the heart of stars that died long before our sun was born. Some may have originated in galaxies long since consumed by our own. You are, quite literally, part of the Milky Way's journey, a living, breathing chapter of its memory. You're built from star remnants. And here you are, listening to the light those ancient stars left behind. The galaxy isn't just out there in the sky. You carry it within you. Chapter 8. The Invisible Architects. If galaxies are the great cities of the universe, then who, or what, built them? Who laid down the invisible framework that keeps their stars tethered, stopping them from scattering into the cosmic wind? As it turns out, three unlikely forces have been shaping the universe from the very beginning: gravity, dark matter, and black holes. Not exactly the warmest trio. None of them shines, sings, or stars in bedtime stories. But without them, the cosmos would be scattered, empty, and directionless. Let's start with gravity, the most familiar of the three. Gravity is the universe's great gatherer. It doesn't yell or sprint. It simply pulls, endlessly, patiently, and always with purpose. In the aftermath of the Big Bang, as the universe expanded in all directions, gravity was the force that began to pull matter together. It gently amplified the tiniest irregularities, faint ripples in space, until they snowballed into structures. Gas and dark matter coalesced, laying the groundwork for stars and galaxies to form. Gravity is quiet, steady, and tireless. But here's the twist. It's actually the weakest of the four fundamental forces we know. Drop a paperclip, and gravity brings it to the ground. But wave a small magnet over it, and suddenly that same paperclip defies the pull of an entire planet. So, how does gravity run the universe? Because it adds up. Unlike electric or magnetic forces, which can cancel each other out, gravity always pulls. The more mass you have, the more gravitational influence you wield. And in space, where there's no air, no friction, nothing to slow things down, that consistent pull becomes incredibly powerful over time. Still, gravity alone didn't explain everything. When astronomers studied galaxies closely, measuring how fast their stars moved, they noticed something strange. Stars far from a galaxy's center were orbiting much too fast. Based on the visible mass, the stars and gas, they should have flung outward like sparks from a spinning wheel. But they didn't. They held their ground. Stable. Predictable. Loyal. This wasn't just curious, it was a problem. Something was missing. There had to be more mass than we could see. Enter dark matter, a type of matter we can't observe directly. We can't touch it, smell it, or photograph it. And yet, its gravitational pull is unmistakable. Dark matter doesn't emit or reflect light, but it pulls, and it's abundant. In fact, it makes up roughly 5 times more mass than the regular matter we can detect. So for every glowing star or shimmering gas cloud we see, there's a massive invisible halo surrounding it, holding everything together. Imagine a galaxy as a glowing jellyfish, suspended within an enormous invisible dome. That dome is the dark matter halo, and without it, the galaxy would unravel. Its stars would drift apart. Its spiral arms wouldn't last. Truth is, galaxies might never have formed at all without dark matter. Even today, we don't fully understand what dark matter is. Some theories suggest exotic particles. Others propose new physics or even hidden dimensions. Nothing has been proven, but the evidence for dark matter is overwhelming. Like feeling the breeze on your skin, you don't have to see it to know it's real. And as if galaxies weren't already complex enough, we come to the third architect: black holes. Not just any black holes, supermassive ones. These colossal objects sit at the heart of nearly every large galaxy we've studied, including our own. Their mass ranges from millions to billions of times that of our sun. They're often painted as destructive forces, and yes, they can be. But they're also quiet regulators, shaping the very galaxies they reside in. We once thought these black holes were just galactic tagalongs, forming after the galaxy itself. But evidence now shows they've played a much deeper role. Their growth closely mirrors the development of their host galaxies. They've been writing the story together from the beginning. When supermassive black holes feed, swallowing gas and dust, they release staggering amounts of energy, sometimes more than the combined output of every star in the galaxy. This energy can blast away surrounding gas, halting star formation for millions of years. So these black holes don't just consume, they govern. They influence a galaxy's evolution in powerful, lasting ways. This process, known as feedback, is still being unraveled, but its effects are clear. Black holes can launch plasma jets thousands of light-years long, shifting gas flows and reshaping galactic structures. It's strangely poetic. The darkest, most secretive entities in the universe, the ones that swallow light and defy observation, are also the ones holding the cosmic architecture together. Dark matter, gravity, black holes, the silent architects of existence. And here we are, orbiting an ordinary star in a spiral galaxy, itself nestled in a dark matter halo, circling an unseen supermassive black hole at the center. Every breath we take, every movement we make, unfolds in a universe structured by invisible forces. So, the next time you look up at the stars, remember this. The beauty you see is only the top layer, the shining surface. Beneath it lies the scaffolding, the silent forces, the hidden hands, the constant, unseen craft of creation. They do not glow. They do not speak. But they're always working, always building. Chapter 9. Galactic Collisions. Galaxies may appear serene in photographs, elegant spirals, glowing halos, and soft trails of dust. But don't let the beauty fool you. The universe is anything but quiet. Out in the cosmic vastness, galaxies are always on the move, drifting, spinning, tugged by gravity like dancers caught in an endless, interstellar waltz. And every so often, those dancers drift too close. Their arms entangle, their orbits cross, and they collide. Not with a bang, but with a slow, magnificent performance that can last hundreds of millions, even billions of years. Yes, galaxies do crash into one another. But before you imagine apocalyptic scenes of exploding stars or shattering planets, pause for a moment, because the truth is far more graceful. Even though galaxies are massive in scale, they're made up mostly of empty space. The stars within them are so far apart that even during a full-blown galactic collision, the chances of two stars physically crashing into each other are incredibly slim. It's less like a car wreck and more like two clouds drifting through one another, except these clouds are made of stars, gas, dust, and dark matter, all bound by gravity's relentless pull. While individual stars rarely collide, the galaxies themselves don't emerge unchanged. As they interact, gravitational forces stretch and twist them, warping their shapes into vast, luminous strands of stars, known as tidal tails, that can stretch across hundreds of thousands of light-years. These bright, delicate threads are made of stars flung outward by the gravitational interplay. Gas clouds, on the other hand, don't escape so gently. When these clouds collide, they compress and heat up, often triggering furious bursts of star formation. These starburst galaxies can form new stars at rates dozens or even hundreds of times faster than normal, galactic baby booms fueled by chaos. Some of the most stunning and chaotic galaxies we've ever observed are in the midst of these cosmic mergers. Take the Antennae galaxies, a pair of spirals currently fusing into one. They sport long, sweeping arcs of stars and glowing pockets of new starbirth. A beautiful example of what happens when galaxies cross paths. Eventually, these galaxies will become a single entity. But the result won't be another graceful spiral. Spirals, it turns out, are fragile. They're easily unraveled by the violent ballet of a collision. What remains after the dust settles is usually a large elliptical galaxy, stars thrown into chaotic orbits, gas either consumed in the frenzy or blown into intergalactic space. Without enough raw material left, rebuilding spiral arms isn't possible. This is how many of the universe's largest galaxies came to be, not through gentle growth, but through slow, grinding collisions, like cities formed by the shifting plates of Earth. And this isn't just something from the distant past. Our Milky Way isn't peacefully observing from the sidelines. It, too, is in the midst of ongoing mergers. Right now, our galaxy is slowly absorbing several smaller satellite galaxies. One of them, the Sagittarius dwarf galaxy, is being gently pulled apart, its stars now forming ghostly arcs in our galaxy's outer halo. Other dwarf galaxies follow similar paths, stretched, dismantled, and woven into the fabric of the Milky Way. Then there's Andromeda, our nearest large galactic neighbor. The Andromeda Galaxy is gliding steadily toward us, separated by about 2.5 million light-years, but closing that gap at roughly 110 kilometers per second. It may sound fast, but in cosmic terms, it's a slow, deliberate drift. The collision is expected in about 4 billion years, so no need to start packing. And what happens to us? Surprisingly little, at least in terms of immediate danger. The vast distances between stars mean direct impacts are still unlikely. But the sky will change dramatically. Over time, Andromeda will loom large and brilliant in our night sky, growing until it dominates the heavens. Eventually, the two galaxies will spiral around one another, fuse, and settle into something new, likely a massive elliptical galaxy. Astronomers have even given the future merger a nickname, Milkomeda. Yes, really. Even in the face of cosmic grandeur, scientists sometimes indulge in a little playfulness. But long before that event unfolds, countless other galaxies are already merging. In clusters filled with hundreds or even thousands of galaxies, interactions are constant. Shapes are warped, gas is disturbed, and stars are redistributed, part of the ongoing evolution of cosmic structure. Galaxies are not static. They don't remain frozen in time. Like living systems, they grow, change, and adapt through relationships, gravitational ones, that is. And what may surprise you most is that galactic collisions aren't always destructive. In fact, they're often creative. Collisions can reignite star formation, fuel the growth of central black holes, and completely reshape galaxies, not unlike blending two colors of paint or trimming a tree into something unexpectedly beautiful. In the universe, collisions aren't rare. They're the norm. We tend to imagine the cosmos as still, serene, a quiet expanse of distant stars slowly drifting. But that image is a comforting illusion. The universe is alive with motion. Galaxies fall toward one another, tangle, blend, and birth something new. Their stars merge not just in light, but in narrative. Even now, somewhere in the deep sky, two galaxies are beginning that delicate first approach. They're not heading toward destruction. They're heading toward unity. And from that union, just like countless times before, a new galaxy will rise. It always has. And it always will. Chapter 10: The Light as Memory. To look out into space is to look back in time. It's one of the most quiet yet profound truths about our universe. Every star shining in the night sky, every galaxy glimpsed through a telescope, is not showing us what it is now, but what it was then. Light, even at its astonishing speed, takes time to travel. And space? It's vast. Mind-bendingly vast. Which means when we look up, we're not just observing the heavens. We're witnessing history. Take the sun, for example. The warm sunlight that touches your skin during an afternoon walk actually left the sun's surface about 8 minutes earlier. That means every time you see sunlight, you're seeing light that's already 8 minutes old. You never see the sun as it is, only as it was. Now go beyond our solar system, and the delay becomes even more dramatic. The nearest star system, Alpha Centauri, is over 4 light-years away. So the starlight we see from it is already more than 4 years old. And that faint glow from the Andromeda Galaxy? It started its journey toward us over 2.5 million years ago, long before humans, before writing, before the wheel. That soft shimmer in the sky is a message from a time that predates everything we've ever known. And with the right tools, we can look even deeper. With powerful instruments, we can peer back billions of years, almost to the very beginning. The farther we look, the further back in time we go. It's like peeling open the pages of a cosmic diary, one photon at a time. That's why telescopes are also time machines. Take the Hubble Space Telescope, launched in 1990. Orbiting high above Earth's atmosphere, Hubble revealed wonders we never imagined we'd see. One of its most iconic achievements was the Hubble Deep Field, a deceptively simple experiment. Astronomers aimed Hubble at a patch of sky that looked utterly blank, a seemingly empty void. They let it collect light for several days. And when the images came back, that patch of nothing was bursting with galaxies. Thousands of them, each home to billions of stars. All within a sliver of sky no larger than a grain of sand held at arm's length. Some of those galaxies dated back over 13 billion years. We were looking at light from a time when galaxies were just beginning to take shape. That light had traveled nearly the entire age of the universe just to reach us, crossing impossible distances, passing uncountable wonders, and eventually landing on Hubble's mirror, leaving behind a fragile but enduring imprint. Today, we have a telescope that peers even further, the James Webb Space Telescope, launched in 2021. Webb can dive deeper into the past not just because it's physically larger, though it is, with a mirror over 6 meters wide, but because it sees in infrared, and that makes all the difference. As the universe expands, light from distant galaxies stretches, like taffy, into longer and longer wavelengths. This phenomenon, called redshift, means the oldest galaxies now glow in the infrared, light that's invisible to the human eye, but not to Webb. Where Hubble could only glimpse that ancient glow, Webb was built to absorb it completely. And already, it's changing what we thought we knew. Webb is uncovering galaxies that formed just a few 100 million years after the Big Bang. Some are small, scattered, and chaotic, exactly as expected. But others? They're astonishingly complex, enormous, well-structured, like massive cities rising long before the blueprints were even supposed to exist. These discoveries are challenging long-standing assumptions about galaxy formation. They're rewriting timelines, shifting our understanding of how quickly the early universe organized itself. And here's the strange, poetic twist. The further away a galaxy is, the younger it truly is, but the older it appears to us. Because we're not seeing it as it is now. We're seeing it as it was billions of years ago. So yes, when we look out at the cosmos, we are always seeing the past. And yet, this is exactly how we learn. We don't need to rewind the universe. It's already been sending its memories forward, one photon at a time. We're simply here to catch them, patiently, quietly, with mirrors, gold-coated lenses, and ever-evolving technology. In a sense, this is what science often does. Listen for echoes of what came before. Of course, there's a limit to how far we can see, a boundary known as the cosmic microwave background, the faint afterglow of the Big Bang. It's not that nothing existed before it, but rather that the early universe was opaque. Back then, light couldn't travel freely. It bounced and scattered like headlights in thick fog. Only when the universe cooled and atoms formed did light finally break free and begin its journey to us. That's our visual horizon, the edge of what we can observe. Beyond it lies speculation, mystery, questions we're still working to answer. But even without seeing past that line, what we've already uncovered is breathtaking. Every photo from Webb, every image from Hubble is a portrait of long-lost time. A window into epochs so distant they almost seem imaginary. But they're not. That light is real. It touched something once, a star, a cloud, a galaxy, and now it touches you. So next time you find yourself beneath the stars, remember, you're not just looking up. You're gazing into the past. A deep, unbroken past, where stars still shine from the moment Earth was young, when no eyes had yet opened to see, when no names had yet been spoken. And yet the light endured. It crossed time and space to reach you, right here, right now. The universe doesn't just create stories. It remembers them. Chapter 11. A Living Universe. We've traveled a long way, from the first whispers of matter to the towering spirals and radiant cores of galaxies. We've witnessed the cosmos awaken, take form, and stretch itself outward. And now, as we drift closer to the present, we realize the story isn't finished. Galaxies are still being born, still colliding, still reaching for one another through the endless dark. Because, like people, galaxies don't like being alone. They gather. They form communities, groups, clusters, and vast superclusters. Structures so colossal, they defy comprehension. Our own Milky Way resides in one of these galactic communities, the local group, a relatively quiet patch of the universe made up of over 50 galaxies. Most of them are faint and small, humble dwarf galaxies orbiting the larger ones like celestial companions. The two largest in this neighborhood are us and the Andromeda Galaxy. We're the giants of this galactic cul-de-sac, slowly inching toward one another. We've talked about their eventual collision, but for now, the two remain respectfully distant, aware of each other's presence, not yet close enough to touch. Surrounding us are dozens of smaller companions. Some, like the large and small Magellanic Clouds, are visible in the southern hemisphere and are slowly being drawn into the Milky Way's embrace. Others, like the Draco Dwarf and Ursa Minor Dwarf, are barely visible, faint clusters of stars clinging to their identity as they drift through our dark matter halo. These local gatherings are common, but they're just the beginning. Zoom out, and you'll find galaxy clusters, massive groups containing hundreds or even thousands of galaxies, all bound together by gravity. One such cluster, the Virgo cluster, lies just beyond our own local group, a sprawling assembly packed with spirals, ellipticals, and all manner of galactic forms. In places like this, galaxies don't keep to themselves. They bump, bend, and often collide. Invisible forces stretch across millions of light years, pulling and pressing them into constant motion. These clusters exist within even larger systems, superclusters. Our own, the Lania Chaos supercluster, spans more than 500 million light-years and contains around 100,000 galaxies, each one housing billions of stars, all moving together through space, following the pull of gravity along a web we're only beginning to map. And even that massive structure? Just one thread in the cosmic web. Galaxies aren't scattered randomly. They arrange themselves into filaments, walls, and nodes, forming a sponge-like structure stretched across the blackness of space. These patterns were seeded at the dawn of time, just after the Big Bang, and have been sculpted for billions of years by dark matter's invisible influence and gravity's patient tug. Between the bright strands lie voids, vast, silent expanses where galaxies are few and far between. Some of these voids stretch tens of millions of light-years, cold and quiet, with only the occasional lonely galaxy drifting through, like a boat lost in open sea. It's this contrast, the vibrant clusters and the haunting voids, that outlines the universe's current structure. But not all is expansion. Not everything is still growing. There are signs that the universe's creative rhythm is beginning to slow. Not in speed, but in formation. Many galaxies, especially large, ancient ellipticals, have stopped forming new stars. Their gas, the fuel for starbirth, is either used up or gone. We call these galaxies red and dead, not because they're silent, but because their aging stars glow in soft red hues, and no young stars are taking their place. Even our own Milky Way produces fewer stars now than it did in its youth. It's still active, not finished yet, but its wild, youthful days of rapid star creation are behind it. We've entered a quieter, more contemplative era for galaxies and for the universe as a whole. Meanwhile, the cosmos continues to expand, not just steadily but accelerating, driven by something mysterious we still don't fully understand: dark energy. This force is pushing galaxies farther apart at increasing speed. One day, trillions of years from now, galaxies that aren't gravitationally bound may disappear from view entirely. Their light stretched so far by the expansion of space that it never reaches us. The universe may grow colder, darker, and lonelier, but that's still a long way off. For now, galaxies still collide, still evolve, still astound us. Thanks to Hubble, Webb, and the telescopes yet to come, we're seeing farther into space and deeper into the past than ever before. We're witnessing the quakes of galactic birth, the faint tremors of ancient collisions, the glow of newborn stars and galaxies, so far away their light began its journey before Earth had oceans. Every night sky carries those echoes. Each star you see tells a story, some just beginning, some long since ended, yet all part of a larger tapestry. The visible universe is still unfolding, still shaping itself. And galaxies? They're no longer strangers. They've become our neighbors, our guides. Living evidence that in a universe so vast we can't fully comprehend it, we have a place. And it has a place in us. And now, after countless years and countless miles, we've reached the edge of our journey. We've drifted from the universe's first flicker of existence to the birth of galaxies, from silence into starlight. We've watched suns ignite, gather into brilliant cities of fire, and spin through spirals shaped by invisible hands. We've seen galaxies collide, merge, transform, and grow old, ancient giants in a universe that never truly rests. We've passed through the Milky Way, our own stellar hometown, and felt the quiet influence of black holes and dark matter, the unseen forces holding everything together. We've looked into the past, truly looked, catching light that traveled across unimaginable distances, arriving here just in time to meet us. It's humbling, isn't it? To realize that the stars above aren't just tiny sparks in the sky, but messages, echoes from long ago. That galaxies aren't still photographs, but ongoing stories, still unfolding. And that everything you are, your breath, your body, even the thoughts moving through your mind, was once created in the heart of a star that has long since faded. You are made of galactic dust. You are written into the fabric of the cosmos. Maybe that's why the night sky feels like peace. Why something deep within us quiets when we look up. Because, perhaps, some ancient part of us remembers what it felt like to drift beneath those first lights. So now, as your eyelids grow heavy and your mind begins to wander, I'll ask you once more, just as I did at the beginning. Where in this vast world are you listening from tonight? And what time is it where you are? Feel free to share in the comments if you'd like. I always love seeing where these quiet journeys find their home across the earth. It reminds me how connected we are through wonder, through awe, and through stardust. And if you enjoyed floating through the stars with me tonight, maybe consider tapping the like button or subscribing for more curious adventures. There's still so much left to explore, and I'd be honored to wander through it with you. But for now, rest. Let yourself sleep. Let the stars keep watch. Let the galaxies keep turning, just as they always have. Good night, fellow traveler. You are home among the stars.